What makes a word a word? Really think about it. And how do we, as human beings, just effortlessly create and understand new words, words we've literally never heard before? Today, we're pulling back the curtain on something we do constantly, thousands of times a day, often without even thinking about it. Building and understanding words. We're diving deep into morphology. That's the incredible mental system in your brain that handles word formation.
Right, and it's also the branch of linguistics that studies words, their internal structure, how they're put together.
Exactly. So our mission today is to take this stack of sources. We have articles, research, expert notes, and really pull out the most important nuggets of knowledge for you.
The goal is to give you a shortcut, really, to understanding how linguists think about and analyze the intricate internal structure of complex words.
Yeah, looking across a whole range of real languages. We'll focus on some of the fundamental problems that keep morphologists busy, regardless of their particular theoretical view. So, let's get into it.
Okay, so first off, it might genuinely surprise you just how complex the simple idea of a word actually is.
Right. It's not just about looking for spaces on a page, is it?
Not at all. For example, linguists often make a distinction between word tokens and word types. Think of it this way. If I say, the dog barked at the cat and the cat ran away, how many words did I just use?
Let's see. The dog barked at the cat and the cat ran away. 9. I'd count 9 words there.
Exactly. If you count every single instance, even the repeated ones like the, you're counting word tokens. So the gets counted 3 times.
Okay.
But if we count each unique word only once, no matter how many times it shows up, then the just counts as 1. That's counting word types.
Ah, I see. So for word types, it would be the dog barked at cat and ran away. 8 unique words.
Precisely. 8 word types in that sentence.
Okay, that makes sense.
Yeah.
But what about words that change their form, like sing versus sang or singing? Are those all separate word types, or is there another way to group them?
That's a great question. And it leads us straight to the concept of a lexeme.
A lexeme. Okay.
Think of a lexeme as like the main dictionary entry form. It's a sort of family of words that only differ in their grammatical endings or forms.
Oh, okay.
So sing, sing, sang, and singing. They're all considered part of one single lexeme. We usually represent it by the base form, like in all caps. Sing. It's the core meaning unit.
So following that logic, rabbit and rabbits would be different forms of the same lexeme, rabbit.
Right, exactly right. And those distinct forms that we use in different grammatical contexts, like rabbit for singular and rabbits for plural, those are what we call grammatical words, or sometimes morphosyntactic words. They signal things like number.
Okay. And it gets even more layered, because you also have to think about how we actually say words. I remember reading about phonological words.
Yes. These are units that influence things like stress placement. In French, for instance, the stress nearly always lands on the very last syllable of a phonological word.
Right. And this connects to those interesting little things called clitics, doesn't it?
It does indeed. Clitics are fascinating because syntactically, they behave like separate words, but phonologically, well, they can't stand alone. They have to lean on an adjacent word, what we call the host.
Like contractions in English.
Yeah.
Mary's here.
Perfect example. Or think about how a phrase like for the lake can often sound like one smooth unit, for the lake. The clitic leans on for. They're functionally independent, but kind of acoustically stuck together.
Functionally independent, but acoustically glued. I like that.
And if we zoom in even closer, the absolute smallest linguistic pieces that still carry some grammatical function are called morphemes.
Morphemes, okay.
A morpheme could be a whole word like hand or just a tiny part like the ed in looked. The key is you can't break it down any further into smaller meaningful parts.
Right. And this is where it gets really interesting, because you told me not all morphemes have a concrete shape you can just point to. Sometimes the meaning comes from a change inside the word, not adding something on.
Exactly. It's like the language is using a kind of internal code. These are non-segmental morphemes. Instead of adding a sound segment, the meaning is conveyed by something like a vowel difference or a change in voicing.
Like run versus ran.
Perfect example. Run for present tense, ran for past. There's no ed added. The vowel just shifts. That shift is the morpheme signaling past tense.
Wow.
Or consider breath, the noun, becoming breathe, the verb. That little change in voicing at the end, from voiceless the to voice the, that signals the change from noun to verb, that feature change itself acts like a morpheme.
That is genuinely mind-bending. So it's not always about adding blocks. Sometimes it's about transforming the block itself. And this relates to terms like ablaut and alout.
Precisely. Ablaut is the term for those systematic vowel changes you see in verb families, like sing, sang, sung. It marks different grammatical forms, usually tense or aspect.
Okay, sing, sang, sung. Got it.
And loud often refers to vowel changes in noun pairs, usually singular to plural, where historically a front vowel in a suffix influenced the vowel in the root. Think goose to geese or foot to feet. Again, it's the vowel change itself that carries the grammatical meaning, in this case, plurality.
Goose, geese, foot, feet. Okay, so knowing all this complexity exists, how do linguists actually go about analyzing these word structures? I know the sources emphasize looking at real languages, not just sticking to one theory.
That's right. The approach is really about description and analysis first, understanding how complex words are built in actual languages. It's about figuring out the patterns. And a great language for illustrating this is Clipchamp Jola.
Clipchamp Jola, from Senegal and Gambia.
Yes. It's often used in morphology courses because its morphology, while it looks complicated at first, is actually incredibly regular and systematic.
Regularity and complexity. That sounds interesting. Why does that make it good for teaching?
Because it lets you see the patterns really clearly. Even though there's a lot going on, it follows predictable rules. It's like having a very detailed, well-organized blueprint for a complex machine. You can trace how the different parts fit together.
Makes sense.
And one really prominent feature in Clipchamp Jola, which we might touch on more later, is its pervasive vowel harmony. The vowels within a word have to agree with each other in certain ways. It's very systematic.
And to study these systems, linguists obviously needed a standardized way to write down sounds, right? That brings us to the International Phonetic Alphabet, the IPA.
Absolutely crucial. The IPA, developed way back in the 1880s, aims to provide a unique symbol for every distinct sound across all human languages. It's like the periodic table for speech sounds.
Universal standard.
Though historically, there was actually some resistance among linguists to standardizing transcription, because indifferent goals like creating a practical writing system versus doing detailed phonological analysis sometimes called for different approaches. But the IPA is now the accepted standard for phonetic representation.
Okay, so when linguists analyze these structures using tools like the IPA, what are the main ways they conceptualize how words are built? You mentioned two main approaches.
Yes, broadly speaking, the first is often called the item and arrangement approach.
Item and arrangement, like arranging items.
Pretty much. You see words as being built from component morphemes, the items that are then simply arranged or strung together, concatenated. So books comes from arranging the item book and the item is.
Like Lego bricks. Click book, click that.
Exactly. And this works really well when you have clear, distinct pieces with clear meanings, that one-to-one correspondence.
But I guess it struggles with things like run to ran, where there's no added piece.
You hit the nail on the head. That's where the second approach comes in handy, the item and process model.
Item and process, okay.
Here, you think of complex words as resulting from processes that operate on simpler words. So books isn't book plus, it's the word book undergoing a process or function called make plural.
Ah, so the focus is on the action of changing the word.
Exactly. This view is much better equipped to handle those non-segmental things, vowel changes, tone shifts, stuff like that, where you're not just adding a distinct piece, but modifying the base itself.
That distinction really helps. Item and arrangement for building blocks, item and process for transformations. And this naturally leads us to talking about the different kinds of word building. Let's start with derivation.
Right. Derivation, sometimes called lexeme formation or word formation, is all about creating a new lexeme, a new dictionary entry, essentially. You take one or more existing lexemes and make a new one, often in a different word class.
It's how we expand our vocabulary, create new concepts.
Definitely. And one of the most common ways this happens is through affixation, adding bits and pieces.
Like prefixes and suffixes.
Exactly. Prefixes go at the beginning, or in reignite, unpacked, intolerant.
And suffixes go at the end, which English uses a lot.
Oh, absolutely. Thinkable, insprayable, hood in childhoods, evenism in nationalism or capitalism, evenness and collectiveness or happiness, ease and audition-y, aholic and workaholic. The list goes on and on, even playful ones like alicious or metastic.
And these can stack up, right? Like nation, nationalism, nationalization, conventionalization.
Precisely. Affixation can be recursive. You can keep adding affixes to derived words, and it's not just prefixes and suffixes. Some languages have infixes.
Infixes, they go inside the word.
They do. Tagalog is a classic example. You take the word sulat, meaning right, and you insert the infix after the first consonant to get simulant, which means to write.
Wow. Inside the word.
And then there are circumfixes, which have two parts, one at the beginning and one at the end, that work together as a single morpheme.
Like bookends.
Kind of. We thought Cujamatyola uses ul to mark the subject on verbs. Both parts are needed for that one function.
Okay, affixation is clearly huge. What about just sticking whole words together, compounding?
Another major process, just combining two or more words. Doghouse, greenhouse, deer tick, school bus.
Simple enough. But there are different types, right? Endocentric and exocentric.
That's right. Endocentric compounds have an internal head, usually the second word in English, that determines the basic meaning and category. A goldfish is a type of fish. A school bus is a type of bus.
Okay, the head is inside the compound. Makes sense.
But exocentric compounds, their meaning isn't predictable like that. A figurehead isn't really a type of head. A redhead isn't a type of head either, it's a person with red hair. The meaning is outside the parts.
Ah, I see. Like pickpocket, not a type of pocket.
Exactly. And you can get really complex compounds by nesting them, like that high-voltage electricity grid system supervisor example. It just keeps building.
That's quite a title. Okay, what about when a word just changes its job without changing its form at all?
That's zero derivation or conversion. It's super common in English. The noun mail becomes the verb to mail. The noun chair becomes the verb to chair a meeting. No change in form, just a change in word class. Very efficient.
It really is. Then you have more sort of playful ways of making words, like blending.
Yeah, blending is fun. You mash parts of two words together. Smoke plus fog gives you smog.
Yeah.
Channel plus tunnel gives channel.
Breakfast plus lunch gives brunch.
Classic example. And Hebrew does it too, like fruit plus yogurt gives agurt. We also do clipping a lot, just shortening words. Brazier becomes bra, Robert becomes rob, professor becomes prof.
Very common. Now, some of these processes seem like they happen over time, historically.
Right.
Like back formation.
Yes, back formation is a historical process. It happens when speakers analyze an existing word incorrectly, often thinking it has an affix it doesn't, and then they remove that affix to create a new, simpler word.
Like peddler. People thought was the agent suffix, so they removed it to make the verb peddle.
Exactly. Or editor led to edit. And the classic is charisse, an old singular word borrowed from French. English speakers thought the soissée sounded like a plural, so they dropped it and created the new singular cherry.
That's amazing. The language kind of corrects itself, but based on a misunderstanding.
In a way, yeah. Another historical one is folk etymology. This happens when people encounter an unfamiliar word, often borrowed from another language, and they reinterpret it based on familiar words in their own language, even if the connection is totally wrong.
Like cockroach. Comes from Spanish cucaracha.
Right, but English speakers heard cock and roach and reshaped it. Or woodchuck has nothing to do with chucking wood.
Yeah.
It's from an Algonquian word, achak, or something similar that got reshaped to sound like English words.
Fascinating how words morph based on what we think they mean. And on the more modern, deliberate side, we have acronyms.
Yep, purely orthographic, taking initial letters and pronouncing them as a word. Sishuba, self-contained underwater breathing apparatus. NATO, laser.
And finally, those weird little fossil morphemes. Cranmorphs.
Ah yes, cran in cranberry. Or the huckle in huckleberry. These bits don't seem to mean anything on their own, and they don't appear anywhere else, but they're definitely part of the word's structure. Linguistic remnants, almost.
Okay, so that covers a lot of ways we create new lexemes through derivation. What about the other side of morphology, changing existing words for grammatical reasons? That's inflection, right?
Exactly. Inflection is about creating the different grammatical forms of a single lexeme. Things like tense, number, gender, case. Crucially, the use of inflection is typically required by the syntax of the sentence. You don't choose to make a noun plural. The grammar demands it if you're talking about more than one.
And English, compared to some other languages, has relatively little inflection. We have plural s for nouns, past tense, ed for verbs, s for third-person singular present verbs, s for progressive. But that's mostly it for the regular stuff.
That's true. Languages like Latin, ancient Greek, Russian, or even Old English had and have much more expensive inflectional systems. One word could have many, many different endings depending on its role.
So what are the main categories inflection covers? Number is a big one.
Definitely. Most familiar is singular versus plural. But some languages, like Yupik, Eskimo, or Slovene, also have a dual number, specifically for talking about two of something.
2 eyes, 2 hands. Makes sense.
And even in English, while we have irregular plurals like children, feet, oxen, fish, or sheep, which has a 0 plural marker,
Right, the weird ones.
we also have a highly productive default rule. If I give you a totally new noun, like say wug, you instantly know the plural is wugs.
Bugs, yeah, automatically.
That's the default Hess suffix, which attaches productively to new words.
Okay. Then there's gender or noun class. This isn't always about biological sex, right?
Not at all, though sometimes it aligns. It's basically a grammatical grouping of nouns in a language. Sometimes it's semantic, based on meaning like sex in French or Spanish, livre la table, or animacy versus inanimacy in some North American languages.
But sometimes it seems totally random. Like in German, the word for girl, Mädchen, is grammatically neuter.
Exactly. It can be purely formal or arbitrary. And going back to Clipchamp, it has an amazing system with 19 different noun classes.
19.
Marked by different singular and plural prefixes. And these classes aren't just arbitrary. They can convey subtle meanings, diminutives, making something small, augmentatives, making something large, personification, even dehumanization.
So the class a noun belongs to can add meaning.
Yes. And what's really wild is that in Clipchamp, even verb infinitives take noun class prefixes, but the choice of prefix depends on purely phonological factors, like the number of syllables in the verb stem, not its meaning.
The sound dictates the grammar. That's complex. Okay, what else does inflection cover? Case.
Right. Case marks the grammatical function of a noun or pronoun in a sentence. Is it the subject, nominative, the possessor, genitive, the indirect object, dative, the direct object, accusative? Some languages use case marking extensively, like Latin or German. Others, like English, mostly only show it on pronouns, you may, him, she, her, etc. Some languages have ergative absolutive systems, which mark subjects differently depending on the type of verb.
Okay, and for verbs, lots of inflection there usually.
Oh, yes. Verbal inflection covers categories related to the event or state being described. Tense is familiar locating the event in time, past, present, future. English marks past tense, like departs versus departed.
Right.
Then there's aspect, which is about how the event unfolds in time. Is it ongoing, imperfective, or completed?
Perfective.
Russian is famous for this distinction, like legit to be treating ongoing versus vylechit to treat successfully completed.
So not just when it happened, but how it happened over time.
Exactly. Other aspects can include inceptive, beginning in action, continuative, continuing, completive, finishing. Then there's mood, indicating the speaker's attitude or commitment, like possibility, may, necessity, must, or indicative, stating a fact.
And voice.
Voice relates the participants to the event, most commonly active versus passive. In the active voice, the subject performs the action. The dog chased the cat. In the passive, the subject receives the action. The cat was chased by the dog. Clipchamp, for instance, has a passive suffix I.
Okay, lots of grammatical information packed into verbs. Now, sometimes the different forms of a word seem totally unrelated, like go and went.
Ah, yes, that's suppletion. It's when the different inflected forms of a lexeme are not morphologically related at all. You can't predict went from go using any regular rule.
Or am, is, are, was, were. They're all over the place.
The ultimate suppletive verb. Suppletion often happens with very high-frequency words. Because we use them so often, it's efficient just to memorize the irregular forms rather than compute them by rule every time.
So our brains take a shortcut for the common stuff.
Pretty much. And sometimes you get partial suppletion where there's some phonological similarity, but it's still irregular, like catch becoming caught or think becoming thought. The beginning sounds are related, but the rest changes unpredictably.
Right, not quite catched or thinked.
Then there's reduplication, repeating all or part of the base word. This can be inflectional, like in Samoan, where repeating part of a verb or noun can indicate plurality or intensity. Or it can be derivational, like in English wishy-washy or hocus pocus, suggesting vagueness or deception.
Wishy-washy.
Yeah.
That works.
And finally, languages often have various stem alternations, especially with verbs. Latin, for example, had distinct present stems and perfective stems for many verbs, requiring learners to memorize both. The stem itself changes depending on the tense or aspect.
Okay. So all these different ways words change shape, adding things, changing vowels, using totally different forms, it really highlights the interplay between the form of the morphemes and the sounds of the language. This is more of phonology, right?
Exactly. Morphophonology studies how morphology and phonology interact. A key concept here is allomorphs.
Allomorphs, different forms of the same morpheme.
Precisely. They are different phonetic realizations of the same morpheme, depending on the context. The English plural morpheme is a perfect example. It has the allomorph s after voiceless sounds, cats after voiced sounds, dogs, and res after sibilants, roses, bushes.
Cats, dogs, roses. Same meaning, plural, different sounds.
And don't forget the irregulars. The plural morpheme also has the allomorph n, or syllabic n, in oxen, and even a zero allomorph a in sheep or fish, where the plural looks the same as the singular. All different ways of realizing the plural meaning.
So why do we get these different sounds like s, and jez?
Often it's due to phonological processes like assimilation. The voicing of the plural suffix matches the voicing of the preceding consonant. Voiceless T in cat leads to voiceless S. Voice G in dog leads to voice Z.
The sounds become more alike.
Exactly. You see assimilation elsewhere, too. The English past tense ed suffix is pronounced T after voiceless sounds, jumped, and D after voiced sounds, rubbed. Or, in Spanish, the N in the prefix con often assimilates to the place of articulation of the following consonant.
Okay. And another reason for allomorphs.
Epenthesis, inserting a sound segment, usually a vowel, often to break up tricky consonant clusters or avoid vowel sequences. That schwas, plural in English, roses, bushes, involves inserting the schwa vowel to separate the sibilant at the end of the stem from the sibilant of the suffix.
Makes it easier to pronounce bouches than bushes.
Exactly. Or in French, liaison often involves pronouncing a normally silent final consonant before a vowel initial word, like les amis, which can be seen as selecting a different allomorph of les in that context.
It's like the sounds are constantly negotiating with each other to make things flow better.
That's a good way to put it. And sometimes the shape of morphemes is dictated not just by adjacent sounds, but by larger phonological structures like syllables or feet. This is prosodic morphology.
Prosodic morphology.
Like
Rhythm and structure influencing word shapes.
Yes. The most famous example is probably the root and pattern morphology found in Semitic languages like Hebrew and Arabic.
Ah, the three consonant roots.
Exactly. You have a consonantal root, typically three consonants like KTB for right in Arabic or MLK for ruliking in Hebrew. This root carries the core lexical meaning.
KTB, MLK.
Then grammatical information like verb tense, noun formation, passive voice is conveyed by interleaving specific vowel patterns and sometimes adding affixes with that consonantal root.
So you take the KTB skeleton and weave in vowels.
Precisely. KTB plus the vowel pattern A gives karaba, he wrote. KTB plus MA gives kapti, writer. MLK plus A gives Hebrew melex, king. MLK plus A gives melex, he reigned. The vowel pattern is the grammatical morpheme superimposed onto the root. It's a fundamentally different way of building words than just adding affixes linearly.
That is incredibly elegant. So different from English. Speaking of English, you mentioned earlier a distinction between primary and secondary affixes. What was that about again?
Stress?
Yes, it relates to stress shifts. Primary affixes, which often have Latin or Romance origins like ion or nitidi, tend to cause the main stress of the word to shift. Compare Mendel with Mendelian or productive with productivity. The stress moves.
Mendelian. Productivity. Okay, I hear it.
But secondary affixes, often from Germanic origins like Tianus, Cetin, Heiklis, Schitoder, or Keenism, usually do not shift the stress. The stress stays where it was on the base word. Happy becomes happiness. Nation becomes national. National becomes nationalism. The stress stays put.
Happiness, nationalism, right? No shift. That's a subtle but consistent pattern.
It is, and it reflects the different historical layers of English vocabulary. These patterns also evolve over time through various historical processes. One interesting concept is linguistic exaptation.
Exaptation, like in evolutionary biology. A trait evolved for one thing gets used for another. Exactly the same idea. A linguistic structure may be an affix or a construction that originally developed for one function gets co-opted or repurposed for a new function over time.
Can you give an example?
Sure. There was a Latin suffix sco, an inchoative marker meaning to begin to do X or to become X. It survived into Italian as isc, but it lost that original begin to meaning. Now it just marks certain verb conjugations in the present tense for a particular class of verbs. Its function changed completely. It was exapted.
So it found a new job in the language.
Pretty much. We also see historical changes like leveling. This is where variations within a paradigm, say, different stem forms for a verb get simplified over time, making the forms more similar to each other. One form gets generalized.
Like maybe irregular verbs becoming regular, like helped instead of an older help.
That's a type of leveling, yes. Or sometimes an alternation that applied to only some forms gets spread to others. For example, some Spanish verbs historically had a nasal infix only in the first person singular present, rompo, from romper, to break. But this nasal got leveled or generalized to other forms in some dialects or related languages. The paradigm becomes more uniform.
Making things simpler, more consistent.
Often, yes. And related to this is analogy, particularly four-part analogy. This is a major force driving morphological change. It's when speakers extend a pattern from one set of words to another.
Like A is to B, so C is to X.
Exactly. The classic example is the English plural of cow. It used to be kine, which was irregular, but speakers saw the regular pattern. Stone is to stones, book is to books. So by analogy, cow should be to cows, and eventually, cows replaced kine.
So the regular pattern won out through analogy.
It often does, especially if the irregular form isn't super high frequency. These historical forces, exaptation, leveling, analogy, are constantly reshaping the morphology of languages.
And even things that seem artificial, like secret languages, Pig Latin or French Verlan, where they reverse syllables. They actually how deeply ingrained these morphological and phonological rules are, right?
Absolutely. To speak Pig Latin correctly, ig peetin le, you need to unconsciously know how to identify the beginning consonants, the onset of a syllable, and apply a consistent rule. Verlan requires manipulating syllables. It shows we have implicit knowledge of these prosodic units and rules, even when playing with language.
Okay, so we have all these processes for building and changing words. How does this all fit into our minds? Let's talk about the mental lexicon.
Right. The mental lexicon is essentially your internal dictionary. It's where linguists believe we store information about words, their sounds, meanings, grammatical properties, and critically, any unpredictable or irregular forms.
Like went for go or geese for goose. Those have to be stored, right? You can't generate them by rule.
Exactly. They're stored as whole units. But this leads to a really big debate in psycholinguistics, the storage versus rules debate. For complex words, especially regularly formed ones like walked or books or unhappiness, do we store them as whole units too, or do we construct them on the fly using rules?
So when I say unbreakable, am I pulling that whole word out of my mental dictionary, or am I quickly combining un plus break plus able using rules?
That's the million-dollar question. The current thinking is that it's likely a combination, a sort of dual system. Highly frequent, complex words might be stored whole for faster access. Less frequent ones might be constructed by rule.
And maybe depends on the frequency of the parts, too. Like if the root break is common, maybe we build words from it.
Exactly. Factors like overall word frequency, the frequency of the base word, and the frequency and productivity of the affix all seem to play a role. It's why irregularities tend to survive in very high-frequency words like be or go. We use them so often, storing the irregular forms is efficient. For less common words, relying on rules might be more economical memory-wise.
That makes intuitive sense. This idea of rules leads to productivity, right? How readily can we use a rule to make new words?
Precisely. Productivity refers to the extent to which a morphological process like adding a suffix can be used freely and creatively to form new words, including words we've never heard before.
And it's not all or nothing, is it? Some rules are more productive than others.
Definitely not. The plural s in English is highly productive. The suffix that forms nouns like warmth or width is much less productive. You can't easily make coolth or narrowth. Productivity exists on a scale.
What limits productivity? Why can't we just stick any affix on any word?
There are various constraints. Phonological constraints, for instance, the comparative in English prefers shorter, usually one or two syllable adjectives, happier, nicer. Longer adjectives usually require more beautiful, beautifuler.
Okay, the sound pattern matters.
Morphological constraints. Some affixes might only attach to bases that don't already have suffixes, or only to bases from a specific origin, like Latinate versus Germanic.
Can't stack certain things.
Syntactic constraints. The affix might require a specific word class. The English prefix are redo, rewrite, generally attaches only to verbs. You can't, or chair, or happy.
Only worse on verse.
And semantic constraints. The meaning of the base or the resulting word can matter. You mentioned the English suffix "e" earlier, forming words like employee, interviewee, payee, auditionee, standee.
Right. It just seems quite specific.
It is. Studies suggest E typically attaches to verb bases, and the resulting noun usually refers to a sentient being who is the recipient or undergoes the action of the verb, often without full control and usually in the context of a specific event. You wouldn't call a table an examinee. It doesn't fit the semantic profile.
Wow, it's a lot of conditions for one little suffix. So productivity is limited. And sometimes we don't create a new word simply because a perfectly good one already exists. That's blocking.
Exactly. Blocking is a kind of economy principle in the lexicon. If a well-established word already exists for a particular meaning, it typically blocks the creation of a new, synonymous word via a regular process. For example, the irregular noun thief blocks the formation of stealer, from the verb steal plus agentive,
Even though stealer would be perfectly regular.
Right. Or cook, the person, blocks cooker in that meaning. So cooker gets used for the appliance instead. Tonight blocks this night. It prevents unnecessary proliferation of synonyms.
Keeps the lexicon tidy. Now, the fact that we can create and understand brand new words we've never heard before, nonce forms, that seems like strong evidence for the rules side of the debate, right?
Absolutely. Nonce forms or hapax legomena, words that appear only once in a large body of text, are crucial evidence. When J.K. Rowling coined mugglehood, readers instantly understood it meant the state of being a muggle, applying the productive hose suffix rule. This suggests we actively use these rules to generate and comprehend novel forms.
We're not just retrieving stored items all the time.
It seems not. And fascinatingly, brain imaging studies lend support to these dual system theories. They often show different patterns of brain activity when people process regular forms, like walked, compared to irregular forms, like went, suggesting distinct neural mechanisms might be evolved. Perhaps rule computation versus direct retrieval from memory.
The brain seems to handle them differently.
It appears so. And looking forward, computational morphology is using machine learning hidden Markov models, neural networks, to model these processes. Computers are learning to analyze morphological structures and even generate correct word forms, giving us new insights into how these complex systems might work.
It's like teaching AI the rules of word grammar.
In essence, yes.
Yeah.
Trying to capture that incredible flexibility and rule-governed creativity.
You know, this whole deep dive really underscores the incredible and mostly unconscious linguistic machinery we all have running in our heads. Every single day, you're performing complex morphological analysis without even realizing it. You're navigating and expanding your word knowledge constantly.
It truly is a hidden superpower. We've journeyed deep into morphology today, uncovering these hidden systems, these surprising facts about how words are built and understood, from the tiniest morphemes, those minimal units of meaning,
Like is or funny.
all the way up to the grand architectural theories about how languages structure words. And we've seen that language isn't just about sentences, it's deeply about the intricate internal structure within those words.
Yeah, a structure that varies incredibly across different languages,
Thousands of languages.
yet still seems to hint at some underlying, maybe universal principles of how human language works.
So as a takeaway, you now know that a simple word is actually a really nuanced concept. We have to think about word tokens versus word types, the idea of a lexeme as a family of forms.
Like sing encompassing sing, 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 singing.
Exactly, and distinct grammatical words like rabbit versus rabbits, and even phonological words that influence stress, plus those funny little clitics that lean on other words.
And we saw all the ingenious ways languages create new words through derivation. Elegant compounding like goldfish, subtle zero derivation like to email,
Playful blending like smog, historical accidents like back formation, edit from editor, and folk etymology, cockroach from cucaracha. So much creativity there.
Then we explored inflection, the systematic variations within a single word's family. We marveled at how languages mark number, singular, plural, even dual, gender, or noun class.
Like Kujamat Jola's 19 classes, used for diminutives, augmentatives, all sorts of things.
In case, plus all the verbal stuff.
Yeah.
Tense, aspect, ongoing versus completed action, mood, voice, active, passive.
Yeah.
And now these are some of those marked not by adding things, but by internal changes like ablaut, sing-sang, and laos, uzis.
Or even totally different forms through suppletion.
Yeah, and we definitely grasped the dynamic interplay of sound and form in morphophonology. How allomorphs are different pronunciations of the same morpheme, like the plural e's.
Der Z, driven by processes like assimilation.
How entire language families like Semitic use root and pattern morphology, KTB for right, and how linguistic history leaves its mark through exaptation, repurposing forms, leveling, simplifying paradigms, and analogy, extending patterns like cow-cows.
And finally, we peeked inside your own mental lexicon. It's not just a static dictionary, but this vibrant, dynamic system. It's constantly balancing stored, memorized words, especially irregulars and high-frequency ones, with the ability to create new words on the fly using rules.
Influenced by frequency and guided by principles like productivity, how easily can we make new words, and blocking. Why make a new word if a good one exists?
Well, that balance is key.
So here's a final thought to leave you with. What really stands out to you about this incredible complexity hidden inside every single word you use?
Yeah, think about your own intuitions. How do you know the plural of a made-up word like brox is probably broxes?
That knowledge reflects these deep, unconscious morphological rules you've totally mastered.
And as language keeps evolving, new words are coined every day, patterns shift. How might our understanding of these rules keep adapting?
Maybe the boundaries of our linguistic creativity are way more fluid than we think, constantly reshaping that mental lexicon. What might be the next brilliant, maybe even rule-bending word you hear, or even coin yourself? What does its structure tell us about the amazing, ever-evolving nature of language?